Let's go ahead and look at all blogs and see how it works. So let's start with the main part of the output, and then I'll explain the top part. So for the main part of the output, I'm trying to, when you put the profile ID in, I want to return a table of all the blogs that profile ID is an author of. And you can see that it's an HTML page, and it's got the head and the body. And then you'll see some interesting expressions mixed within this output. That's where you start to see XQuery. This is a very simple example. So what it shows you is for I in, so I being a variable, of all the feeds, of all the entries that have a ID that has blog dash in it, I'm going to return the sequence of those. And you can see that the expression knows to be executed by the fact that I start into an XQuery snippet. But for each one of those I'm going to return another sequence of this table row, and you can see that for each one of those that's returned out of this for iteration, you can see that I'm writing out as a cell, I'm writing out the title and the text of the title. You can see that I'm also writing a small form that will then be used for the next interaction with the website. And you can see that again I'm writing out an embedded expression here for a function that works off of Atom ID. So let's look at this function. If you look at the function, there's a function defined here that's called my_just_blog_id. My is mapped. You can see in XQuery here I'm declaring a namespace called my, and I'm just giving it a namespace identifier so I can make it unique. And here I'm actually declaring a function called just_blog_id. This is an XQuery function implemented exactly in XQuery. And you can see, much like the similar examples in XPath and XSLT and XPath, I implemented as a Java set of logic around some Java beans, and XSLT I implemented as an XSLT function. In XQuery, I'm implementing it as an XQuery function. It looks for the sentinel value, and if the sentinel value of the blog string is all ones, I'm going to return all ones, and that's the way I kind of handle the fake data. But if it's not, then I'm going to look to see if it contains blog dash. I'm going to look for a substring within it. And if I don't recognize any of that, I'm just going to return what was passed into this function. I think the interesting thing here is you can see how I'm declaring namespaces, I'm declaring functions. This, for a lot of folks that are familiar with, say, Java languages or other languages that are similar, this if then else, declaring functions, declaring variables, looks very similar to what they're used to. So it's a little easier to maybe get your head around than someone that hasn't used XSLT and is trying to use XSLT for the same sort of scenario. Also, when I talk about sort of wrapping your head around the concepts, the other one that's very similar here is, this for expression, if it got more complicated, but even in its simple form, is very similar to what you may be used to if you're doing SQL against relational data, but this is XQuery against XML data. The final point is you can see how writing it out in this form of embedded expressions within the content itself may be closer to what you're used to if you're used to using JSPs and being able to sort of mix logic with the actual content. So let's look at the more complicated all comments XQuery. So this all blogs, it was just taking the blog data and returning a table of all the blogs that a profile ID had. The all comments XQuery, its business logic is that it takes all the comments that come back off of a specific blog and it returns again a table of any comments that may be questionable, so you could actually go delete those comments. Um, I show you this example as it gets a little bit more complicated, and it shows the full power of Flower. So you can see now I'm returning for I in comments, and here's comments declared as a variable. You can see I'm declaring a variable as comments, and I'm saying that it will be all the feed entries whose name is anonymous, or all the feed entries whose um, entry matches vulgar words. This is using regular expressions, or any feed entry and calling back to that Java extension function based on any content text that runs some existing business logic in Java. So any of the entries that match any of those conditions, we're going to return if they are published within a date range that was specified by the duration that we passed into the execution back in the API call. So I define the comments variable, and then I can refer to it later as just simple comments. And I can say order by, that's fairly similar to what you may be used to in a SQL sense. I want to order by the author's name. And I want to return back a table, and in that table I want the first row to have the author's name, and I want to have the date on which it was published, and in the next row of the table I want the link so I can easily click on it and go delete it. Also, I finally want just the content so I can actually view the content. You can see that it's much like the previous example, embedded within the HTML page that we run these expressions, these XQuery expressions, right within the output that's going to go back to the browser. Finally, I'd say, much like the XSLT example that we showed previously, you can see that this is working with XML in its sort of native form. If you go back to the servlet, you can see that when I actually execute this business logic, when the servlet request happens, I give it some data. I go straight from the XML source, and I write the output right to the output, which in both cases is HTML or XHTML data. I'm not having to inflate sort of Java objects as I do the transformation or the querying that's happening in XQuery here, and you get sort of the true benefit of doing this in a very XML-centric way. The other benefit here of XQuery is for people that are sort of like this programming style of expression sort of mixed within literal content. It may be a little easier than someone that may not be familiar with XSLT for sort of doing the same thing. XQuery itself is much more complex than this. You can get into very interesting queries across multiple data sources that you wouldn't want to try to do in the XSLT language. We should look at an example eventually where we sort of mix and match. A very common pattern for XQuery and XSLT is that you're using XQuery to query multiple data sources, and maybe even pushing that down into an XML database that has some level of XQuery support, where we can query across very large data sets and complex joins across multiple data sets. And you bring that back into a set of XML data that then can be transformed through XSLT for presentation. And the power of XQuery for doing this querying and joining matched with XSLT for doing the transformation for presentation is a very, very powerful combination. So hopefully this end-to-end sample will help you learn XQuery and how that you can use it within a Java application.